Firstly, we need to convert the absolute value expression into a piecewise function. And then we use one-sided limit to evaluate this expression so we can determine whether the limit exists or not. Let's take a look at our conversion template. We have a template here that says that the absolute value of an expression, or the argument here, is gonna equal the expression itself if we know that the expression is greater than or equal to 0. And instead, when we know that the expression is less than 0, then we must put a extra negative sign in front of it when we remove the absolute value. For example, absolute value of 5 is converted to 5 itself, so we remove the absolute value without doing anything. That is because we know the 5 number is greater than or equal to 0. But when it comes to absolute value of -2, then this will be converted as negative of a -2, which is 2. That is because we know -2 is less than 0. So we use this expression. Okay, so after understanding the concept of how to convert this into a piecewise function, let's take a look at how we can convert this absolute value of x minus 3. Using the template, we're going to have x minus 3 absolute value converted as x minus 3 itself if x minus 3 is greater than or equal to 0. And then we have negative of x minus 3 if x minus 3 is less than 0. Okay, so still we have this inequality here which we can solve to simplify this expression even further. So instead of writing x minus 3 greater than 0, I can think of it as moving -3 to the right side, so it becomes x greater than or equal to 3. And similarly, I can do it for the other expression by moving 3 to the other side. So I have x less than 3. Now we have successfully converted this absolute value into a piecewise function. And we know when to use which piece depending on the what range the variable x falls in. If x is greater than 3, then we use this. If x is less than 3, then we use that. Next, let's go to step 2, using one-sided limit to evaluate this expression. We're going to take a look at x approaches 3 from the right side of x minus 3 divided by x squared minus 9. And we can draw a number line here to indicate how we do it. So 3 is here, approaching from the right side, means that x value is going to be greater than or equal to 3. So that tells us we should use first expression, right, to replace the absolute value. So now I can replace my absolute value simply with x minus 3. And then for the bottom, we will apply the difference of squares formula to write that as x minus 3, x plus 3. And we see we can cancel x minus 3 on the top and the bottom, which is leaving us with 1 divided by x plus 3. So we can just find a limit by plugging x equal to 3 into the expression. That is 3 plus 3, which is 1 over 6. Similarly, we do it for the left side limit. Approaching from the left, we're going to have x value less than or equal to 3. So we're going to use the second expression to replace x minus 3 absolute value. So now we have negative of x minus 3 divided by the same thing. And then we cancel x minus 3. leaving us with -1 divided by that. So we can plug in -1, 3 by 3, and that comes to -1/6. And since we have seen that left side limit is not the same as the right side limit, so we can conclude the limit does not exist. Since limit approaches from the right of this is not equal to the limit approaches from the left the overall limit x approaches 3 does not exist.